Hello, everyone, and welcome to Backer Breaks It Down. In this lesson, we are going to partition a line segment. So we're going to find the point on a directed line segment between two given points that partitions the segment into a given ratio. All right, so directed line segment. It's a segment between 2 points A and B with a specified direction. Okay, that's important because we go from A to B versus B to A, those are two different directions. So we have to pay attention to direction. To partition a directed line segment is to divide it into two segments with a given ratio. Now, to do this, you want to determine the number of parts you're really dividing the segment into. Okay, and so we have this little illustration here. It says point P partitions segment AB in a ratio of 2 to 3. And on the right side, you have a ratio of 3 to 2, which is what this bullet point is addressing. Well, how many equal parts are on these segments that have been split into these 2 to 3 or 3 to 2 ratios? 5, you say, and you would be correct. There are 5 individual segments on AB. Okay, 3 plus 2 is 5. So if a line segment is divided into a 3/5 ratio, so 3 to 5, how many parts does it have? 8. So it have 8 equal parts. All right, so far, so good. Okay. So one of the things that we utilize in these partitioning problems is this fraction formed by the ratio. And so if you have a ratio A to B, the fraction formed by it is A over A plus B. It's like part over whole. Right, so there's a difference between like the ratio and then this fraction formed by the ratio, because we're actually going to multiply by this, and this fraction is the distance that point P is from the given starting point of A. So now I'm going to go over like the steps. All right, remember, direction is important. So sketch to determine direction. Pay attention to how they name the line segment, or in the problem, do they say A to B or do they say B to A? All right, but sketch to determine direction. You need to know up or down, left or right. That's what you want to figure out. Then you need to find the rise and the run of the directed line segment. Just like, notice those are the same calculations we do when we're using slope. All right, we're going to find the new distance by multiplying the rise and the run by that fraction formed by the ratio. And then we're going to find P starting at the indicated, starting point and moving in the direction to that we had indicated in that first step. Okay, are you ready? So we sketch, find the rise and the run, multiply by that fraction, and then we're going to translate to find P. Okay, so find the point P along the directed line segment from point A to point B that divides the segment into a 3 to 1 ratio. So step 1, sketch it. So I'm not going to do anything fancy here. I'm just going to roughly sketch this. So like A is -8, -7. So that means it's somewhere here in quadrant 3. And B is 8, 5. So it's somewhere over here in quadrant 1. So when it comes to the direction, I need to go, because I'm going from A to B, I need to go up and right. That's the direction. So the next step, I want to find the rise and the run of the directed line segment. Now those are absolute value bars because I want to use like the positive value because it's a distance. So the rise is the absolute value of y2 minus y1. And so that's going to be the absolute value of 12, which is just 12. And then I'm going to calculate the run. And let's see, I'm at the absolute value of 8 minus negative 8. I'll move this up in a second. So the run is 16. The next step is, well, it says find the new distance. I need to multiply each of these by the fraction formed by the ratio. So my ratio is 3 to 1. Which means my fraction, remember, it's part over whole, is going to be part, which is 3, over the whole thing, which is 4. So I want to multiply my rise and my run by 3 over 4. Wow, I really don't have a lot of room over there, do I? I apologize for that. Sorry. So 12 times 3 over 4, maybe I'll just do it over here. And this is going to be the new rise. So that's 36 over 4, so that's 9. And the run, I'm doing 16 times 3 over 4. So that would be 12. 48 over 4 is 12. Right, and now I'm going to find point P. I'm going to start at that indicated starting point and move in the new distance in the original direction. So basically, I'm going to go from point A, and I'm going to go 9 up, and I'm going to go 12 units to the right, because remember, that was my original direction. All right. So A is at negative 8, 7. And from there, I want to go up 9, and I want to go right 12. So going up 9 is going to increase the y coordinate by 9 units. So if I go negative 7 plus 9, point P has a y coordinate of 2. And then I want to go right 12. And so that's going to move it in the positive direction. So I want to go negative 8 plus 12, and that's 4. So the coordinates of P is 4, 2. It's really messy. I'm sorry about that. Okay. So let's take a look at one more example. All right. I'll try and be a little neater. Find the point Q along the directed line segment from point R to point S that divides the segment in the ratio 3 to 7. So the first thing I do is I sketch to determine direction. So R is negative 2, 4. So that puts it in quadrant 2. And S is 18, negative 6, which puts it somewhere in quadrant 4. So my direction from R to S is down and right. So down and right. Next, I want to find the rise and the run. Right. So the rise, I'm going to take the absolute value of the difference in the y's. So negative 6 minus 4. That's negative 10. The absolute value of which is positive 10. And then the run, it's supposed to be a different color, is 18 minus negative 2. And I want the absolute value, so that's 20. I'm going to find the new distance. I just need to know what that fraction formed by the ratio is. So if my ratio is 3 to 7, the fraction would be 3 over 10. So I'm going to multiply each of these by 3 over 10, to get the new rise and the new run. So here I get 3, and here I get 6. So this is the new distance that I'm going to go down and right. So I'm going to go 3 down and 6 to the right. So I'm going to start at my point R, and R was -2, +4. And from here, I'm going to get my new point. Sorry, it's actually Q this time. Okay. So first I go down 3. So that's going to affect my Y value. If I'm at 4 and I go down 3, that puts me at 1. And then I'm going to go right 6. So if I'm currently at -2 and I go right 6, that's going to put me at +4. So the point Q has the coordinates 4, 1. So this is as simple as I can get it in 4 steps, partitioning a line segment. Step 1, sketch to determine direction. Step 2, find the rise and the run. Step 3, multiply these by that fraction that you get from the ratio. And lastly, translate. And that's how Becker breaks it down.